Okay, so for example number 3, it asks us to refer to example number 3 that they worked in the book. So I went to their example number 3. They had a woman who worked. She was making some payments. This was her interest rate, 6.85. She was making those deposits for 10 years. And at the end of 10 years, she had, she was depositing $2,000. It was compounded yearly. She was only making deposits every year. So for 10 years, she made this, and this is how much money she had at the end of 10 years. Then she just kept that money in there, and that money, um, earning this much interest for the 25 years turned into this much money. So $143,785.10. That's what Mary has. And it says that Mary is going to use the same interest rate, so 6.85% interest. She's going to do 25 years. She is going to use the same interest rate. She's going to make a payment once a year. Um, and each year, and it is compounded annually because that's what it said up here, compounded annually. So now we just go back to do a payment. So I'm calculating a payment. How much does Mary need to calculate? How much does Mary need to deposit? So we use that same formula that we used right here. Oops. We use this payment formula. So we take our future value, that's how much Jane has, and plug in all those numbers, and that's what I did right here. This is Jane's money. This is the interest rate. It's for 25 years, compounded annually. So calculated that, and it comes out to be, ooh, not that. What in heaven's name did I do wrong? It's definitely not that much money because I did it on the should just be $2,000. What is wrong with my formula? 1 plus raised to the 25 minus 1 divided by that. I don't know what I did wrong. I figured out what I did wrong. I didn't flip this upside down. So this formula was not the right one. I was supposed to have the interest rate alone on top and all of this addition and subtraction stuff on the bottom. So I had it upside down. You go back over here, you type it in there correct, and there it is. The payment, the yearly payment that Mary needs to make is $2,322.73. And given that she makes that payment at this interest rate for 25 years, this is how much money she'll have at the end of 25 years. So for this last example, the book doesn't even try to solve this out algebraically. It's possible, but it is extremely complicated because we've got an I on top and an I on bottom. So the first thing we'd have to do is multiply both sides by I, and then we would have to figure out a way how to get this I together with this I. And it's going to involve taking the 20th root. Yeah, it's very complicated. So what they did for this one was they said, well, you can use the calculator, and they suggested using, let me show you what the book said. They suggested using the calculator to do graphing, or to use, and this is an example of an 84, but the Inspire will do this too. But they suggested graphing, which I will show you, but fixing the window is the problem with that. You can certainly type one side of the problem on one line, type the other side of the equal sign on a second line and then find where they intersect. Again, the problem is knowing how to set the window, because when you graph this, you will not see anything at first. It will just look like a blank screen because your window will not be set right. And it's difficult. You have to think really hard about how to set the window. Using this to solve the problem is definitely an option, but for heaven's sakes, why don't you just use the program in the calculator that will find the interest? So that's what I suggest doing. I will show you the graphing part, but this is the way I would suggest you do it. If you're looking for interest, let me get this problem back up. If you're looking for the interest, so here's the problem that we've got to go through and solve. So how many payments do we have? We're going to have 20, right? Because we're just doing it for 20 years, and it says it is it's an ordinary annual deposits of $1,000. So we're going to do it for 20 years. So annual deposits, that means once a year for 20 years. This is what we're trying to calculate. So that needs to be left 0. We don't have I keep wanting to say previous, but it's not previous. It's present. Good grief. Could not find that word. It's we don't have a present value. We are going to be making annual deposits of $1,000. You have to be sure you put a negative sign right here, because if you don't, you will get an error message. We want $55,000 to be how much we have in the account. So we're going to put $55,000 right here. Payments per year, we've already said that we were just having one, and it is compounded, annually compounded, so we're just going to have one. Payments per year, compounded per year. As this one changes, this one does too. That's why I think those should always be the same, will always be the same. You go back here and you just press enter. And so that means that my interest rate will need to be 9.64% interest. Now, I said I would show you how to do it on the calculator. On the calculator, you would just you would need a graphing screen. So I would you see this right here. It says add a page. So Control Doc. And we need a graphs page. You would go here, type in 55,000. You would go to the second line. I press down, and you would type in this. You would have to use X instead of I, because X is the only variable that will graph. So you're going to open parentheses, and you're going to do 1 plus X, and we're going to close the parentheses, and then we're going to raise that to the 20th power. And then since we want all of that, I think I'm going to have to go back and put in another parentheses. No, wait. Yes, I do need another parentheses, but I'm going to put -1 first. And then so all of that is in the numerator. So then I'm going to say divided by X. And I don't know why the X is capitalized. That's bothering me. And we do see something, but it's not what we expected. It's not what was like in the book. And the reason is because of our window. You have to go here. You have to go to window settings. Our y-axis is only going up to 6. We need it to go up to like 60,000. So that number right there needs to be like 60,000. And we're looking for percentage points. So my x-axis doesn't need to be any bigger than -1 to +1. It doesn't even really need to be -1, but that'll put the x-axis right in the middle. So we press that and we say OK. I still don't see this one right here. Why that one's not graphing. 55,000, there should be, oh, there it is right there. So we've got those two things graphed and that point of intersection. The way we find the point of intersection is we go menu, we analyze the graph, and we find the intersection. And it wants to know of intersection of what? Of that and that. And there they found it right there, 0.96. I don't know how we could see more decimals. I'm sure there's a way to fix it, but we would at least get the 9.6 right there. You can do the same thing on Desmos. Where did my Desmos calculator go? I put y equals 55,000 right here. I put that equation. It's a little bit easier to write the equation on Desmos. I did have to change my window, and I went here to the window settings. I made the x-axis be just -1 to +1 because I'm seeing decimal values. I'm looking at percentages, so that's all I need are decimal values. And then I put the y-axis up to, I guess, 80,000. I did kind of scoot it around a little bit. And all you do to find the intersection there is just go touch the intersection. And it shows you right there it's 9.64%. Desmos at least gave me more decimals. I'm sure your calculator can be set to give you more decimals, but that's all it's given you right now. So that's how you're going to find interest. Again, I would strongly suggest that you just use I don't want to hit the escape key. I want to do, yeah, I suggest you just use the finance solver and do it that way. That would be my suggestion.